fx equals x.
First you find the symmetry, and for this function, it's odd.
Next, we find the boundaries. Since this is linear, there are no bounds.
Since this is a linear function, there are no asymptotes, and the discontinuity is continuous because we drew the function without picking up our pencil.
It's increasing from negative infinity to infinity because it is going up from negative infinity to infinity.
There are no extrema since this is a linear function.
The domain is negative infinity, infinity, and the range is infinity, infinity.
Its end behavior, the limits as x approaches infinity is infinity, and as x approaches negative infinity is negative infinity.
And for f of x equals x squared, the domain is negative infinity to infinity, and then the range is 0 to infinity.
The symmetry is even and it is bounded below.
It has no asymptotes.
And it increases from 0 to infinity and decreases from negative infinity to 0. Its extrema is at an absolute minimum of 0 at x equals 0.
Its limits are when x goes to infinity, it's infinity, and when x goes to negative infinity, y is infinity.
Okay, so this is the graph to the equation f of x equals x cubed. The symmetry is odd and it is not bounded. Also, there are no asymptotes. This graph is continuous with x at 0.
This equation only increases from negative infinity to infinity. There is no extrema, and the domain is negative infinity, infinity, and the range is negative infinity, infinity. The end behavior as x gets close to infinity is infinity, and the end behavior as x gets closer to negative infinity is negative infinity.
This is the graph for the equation f of x equals 1 over x. The symmetry is odd and is not bounded. There is a horizontal asymptote at y equals 0 and a vertical asymptote at x equals 0. The graph has infinite discontinuity at x equals 0.
The equation only decreases from negative infinity to 0 and 0 to to infinity. There is no extrema, and the domain is negative infinity to 0 to infinity, as is the range. The end behavior as x gets close to infinity is 0, and the end behavior as x gets close to negative infinity is also 0.
Our first basic function is the square root function. The equation for this is f of x equals the square root of x. This function has no symmetry and is bounded below because the line never goes beyond the point 0, 0. There are no asymptotes and it is continuous, meaning that there is no discontinuity.
It increases from 0 to infinity and has an absolute minimum of 0 at x equals 0. The domain and range are bracket 0 to infinity. The end behavior of this function as x approaches infinity is infinity. As x approaches negative infinity, an end behavior does not exist.
The second function is exponential. F of x equals b to the x. When b is greater than 1, it represents growth, and when b is less than 1, it represents decay. With any exponential function, there's always the point 1, 0.
There is no symmetry and it is bounded below. The only asymptote is y equals 0. The graphs are both continuous. Y equals 2 to the x increases from negative infinity to infinity, and y equals 1 over 3 to the x decreases from negative infinity to infinity.
The domain is negative infinity to infinity, and the range is 0 to infinity. The end behavior of y equals 2 to the x approaching infinity is infinity, and approaching negative infinity is 0. The end behavior of y 1/3 to the x approaching infinity is infinity, and approaching negative infinity is 0.
Okay, this is the natural logarithm of x. F of x equals ln x. This function has no bounds, symmetry, extrema, or asymptotes, and it is continuous on all x. It's always increasing. X must be greater than 0 throughout the whole function.
The y value is not limited at all. As x approaches infinity, so does y. The limit as x approaches negative infinity does not exist because x is always greater than 0. The limit of y as x values approach 0 is negative infinity.
In the absolute function, the symmetry is even, the boundedness is bounded below. The function has no asymptotes and the function is continuous.
The function is increasing from 0 to infinity, and it is decreasing from negative infinity to 0. The absolute min of the function is 0 at x equals 0. The domain is negative infinity to infinity. The range is 0 to infinity. And the end behavior of the function, x increasing to infinity is infinity, and x increasing to negative infinity is infinity.
The function f of x equals an integer times x is the greatest integer function. The domain is negative infinity to positive infinity, and the range is y such that y is an element of z. It has no symmetry, and the function is not bounded, as well as not having any asymptotes. It has jump discontinuity at x is an element of z.
It increases from negative infinity to infinity, and there are no extrema. The limit of the function as x approaches infinity is infinity. The limit of the function as x approaches negative infinity is negative infinity.
The function f of x equals 1 over 1 plus e to the power of negative x is the logistic function. Its domain is negative infinity to infinity, and its range is 0 to 1, excluding 0 and 1. The function has no symmetry and it is not bounded. It has asymptotes at y equals 1 and y equals 0.
This function is continuous. It increases from negative infinity to positive infinity. There are no extrema. The limits f of x approaches infinity is 1. The limit of as f of x approaches negative infinity is 0.
The parent function of the sine function is f of x equals the sine of x. The graph passes through the origin. The domain is all real numbers, and the range is -1 to 1.
The symmetry is odd,
and it is bounded above and below.
There are no asymptotes and the function is continuous.
There's an absolute max of 1 and an absolute min of -1. The limit of the function as x approaches infinity does not exist because it's oscillating, and the limit of the function as x approaches -infinity is the same.
The parent function of the cosine function is f of x equals the cosine of x. The graph passes through the point 0, 1. The domain is all real numbers and the range is -1 to 1.
The symmetry is even. It is bounded above and below.
There are no asymptotes and the function is continuous.
There's an absolute max of 1 and an absolute min of -1. The limit of the function as x approaches infinity does not exist because it is oscillating, and the limit of the function as x approaches -infinity is the same.